How we do this in Verilog? This is how basically we define the logic. We have the result product and there are operands multiplier and multiplicand. Let's say multiplier and multiplicand are of 16 bits and the product is going to be 32 bits. And this is how we define the logic. Whenever any one of the operand changes, basically it's going to perform multiplication. Product, the result will be initialized with 0 and then there are overall 16 bits. So 16 bits for the multiplier and multiplicand. So we run the for loop for 16 times and it's going to always check multiplier of I 1. If this particular bit is high, then you do this like product equal to product plus multiplicand, left shift I. This does multiplication, addition and left shift. We can't implement for loop directly when it comes to assembly, so we need to visualize the logic using while loop. Look at this. So we define the same logic, something like this: while I is less than 16, it's going to continue the loop. And the same logic, if multiplier that particular bit is I, then it's going to do product equal to product plus multiplicand, left shift I. So when it comes to assembly logic, we need to think like this. So here the logic is P product equal to basically multiplier into multiplicand. That's what we want to achieve. So we allocate registers. X5 is going to be destination register, that's for product, X4 for multiplier and X3 for multiplicand. You can't do bit slicing something like this in assembly, it's not possible. So you have to think of the equivalent logic. So in this case we are going to try this. We are going to have value like this. So there is a register X7 and all 32 bits will be like this: 31 bits 0 and the LSB is going to be 1. So all zeros, only the LSB is going to be 1. So we are going to shift this 1 every time and then we are going to multiply that value with the multiplier. That's how we are going to check whether that particular bit is high or not. You can try this logic. You may need to do paperwork. So here if you look at what we do is basically X4 is nothing but multiplier and X7. Look at this. This is how you can check whether that particular bit is high or not. And this is going to shift left every time. So we perform X4 and X7 and the result will be stored in X9. And then we are going to check whether the X9 is same as X7. If it is going to be same as X7, what that means is that particular bit is high. That's how we can check. And then this is going to be pretty straightforward. Look at this equation: X5 equal to X5 plus X3 left shift X8. So in this case X8 is going to be like I variable. So we need to increment X8 every time. X8 is equal to X8 plus 1 and then X7 every time we need to do left shift by 1. So this is going to be like initially LSB, then the next bit will be 1. So this 1 is going to shift continuously every time towards MSB. Look at this. This is how we can write the assembly program. X10 is nothing but loop count, this 16, the maximum value. And X7 is initialized with 1. We need all 31 bits 0 and only LSB as 1. So we are initializing X7 with value 1. It's going to be like 32 tick H0001 and add X8, X0, X0. So we are also initializing X8. X8 is for loop which will be initialized, and this 16 is available in X10. Look at this. And this is like unconditional jump. You can also do that through JAL, or you can say B equal to X0, X0. Either one works fine. So if you are going to use X0 here, obviously it's going to be unconditional jump. So JAL while expression, it comes straight away here and it always checks whether x8 be less than. So x8 is less than x10. What is the value of x10? The loop count 16. So whether x8 is less than x10 as of now, yes, so it goes to loop. And then it does AND operation. Here it's straightforward. So x4 and x7 we are storing it in x9, and then we are checking this condition whether x9 is same as x7. Yes, if it is same, then go to multiplication. That is this logic, right? So here we do the shift x3 by x8, the shift, because x8 is going to increment 0, 1, 2, 3, right? So x3 by the current value, as of now the value is 0. If it is 1, it will left shift by 1. That's what it does. And that value will be stored in the intermediate register x11. This is like kind of new register. And then we do this add operation x5 plus x11, the result will be stored in x5. And then we do unconditional. This is also unconditional jump. If it is same, yes, always it's going to be same, then it goes here. And then these two things we need to do, right? x8 plus 1 and x7 left shift by 1. And then this also does unconditional jump. So while expression comes and then this checks and then the loop continues. The loop is going to continue until it breaks the expression. So if x8 is going to be greater than x10, then it will go to the next statement. The statement could be like writing the result back to data memory.